Hello, everyone. Welcome to our today's episode of Career Stories in Astronomy and Space. And today we have a very special guest with us, Dr. Patrick Dasgupta. He's the professor of the Department of Physics and Astrophysics at Delhi University. Welcome, Patrick, sir.
Thank you.
Yeah, so students will be, right now we're not able to see him visually, but we'll be able to hear him speak. And with me also is Arjun, who will be bringing the questions from YouTube. So all of you are free to ask questions on the YouTube chat. So let me introduce Dr. Patrick Dasgupta. After receiving the National Science Talent Search Scholarship in 1976, he joined BITS Pilani to do a 5 years integrated MSc Physics. In 1981, he took admission in the PhD program at Indian Institute of Science, Bangalore, but left for Tata Institute of Fundamental Research, Mumbai in 1982 as a research scholar in the Theoretical Astrophysics group. There he did his PhD with Professor Jayant Narlikar. During that period, he also collaborated with late Professor Geoffrey Burbidge from the US. Soon after submitting his PhD thesis in 1988, he joined Ayuka Pune as a postdoctoral fellow. During 1989 to 90, he had short stints at the University of Wales, Cardiff, in the UK, as a senior research fellow to learn about gravitational wave data analysis techniques, as well as at the Observatoire de Paris, Meudon, to have an exposure to the topic of gravitational radiation from Hulse-Taylor binary pulsar. During those visits, he worked with Professor Bernard Schultz and Professor Thibaut Damour, respectively. After his return, he published a paper in 1992-93 with Professor Narlikar on gravitational waves from mini creation events in cosmology. He joined the Department of Physics and Astrophysics, University of Delhi, in 1993 and has been a full professor there since 2004. His current research interests include studies related to confirmation of Hawking area theorem from the observed gravitational waves from binary black holes, proposing a unified model for gamma ray bursts and fast radio bursts, modeling dark energy, torsion, and Chern-Simons gravity using a dynamical four-form mechanism to generate supermassive black holes from Bose-Einstein condensation of bosonic dark matter and baryogenesis from primordial black holes. Currently, Patrick Dasgupta is the elected president of the Indian Association of General Relativity and Gravitation. He has also been active in training and leading students for the International Physics Olympiad under the aegis of Homi Bhabha Center for Science Education at TIFR, Mumbai. So, welcome again, Dr. Patrick Dasgupta. You've worked with some of the most famous names in astrophysics, and it's just amazing to see that you've had the opportunity to work with all these people, all the way from Dr. Jayant Narlikar to Bernard Schultz. So I'm very
Thank you, Dr. Mila, for the kind words. So whenever you give me a go, I can start sharing my slides.
yeah. So please go ahead and share your slides and
Thank
tell
you.
us more about your personal career story. And yeah, let's go ahead with that. Let's start about how you got into interested in astrophysics, and please share your story.
Yeah. Uh, is my slide visible?
Yeah, it is visible.
Uh, Great. So first, I will just talk about the excitement uh, concerning research in space and astrophysics, and then we will go to the I don't know why I'm not able to move ahead. One more.
Yeah, there, right there.
That's right.
Yeah.
Yes. Right. So all of us are familiar with one of the greatest event that took place recently, and that is uh, ISRO was the first organization in the entire universe to have successfully launched a Mars orbiter around Mars in its very first attempt. And this is one of the greatest achievements of ISRO to date. Of course, the space research is primarily about studying not only the space between Earth and the moon, but space around the Earth up to the full size of the solar system. That means you go up to Neptune, go beyond Neptune to Pluto, and study the space. But universe is much bigger than that. If you peer at the universe using a very, very powerful telescope, like in this case is the Hubble Space Telescope, then what you see is that the universe is essentially visible to us in the form of giant galaxies. You can see spiral galaxies, you can see elliptical galaxies, you can see another spiral galaxy with the spiral arms, and so on. And obviously, a lot of science and technological innovations go into researching both space and the astrophysical aspects of cosmic objects that interest astronomers. Regarding space, of course, we know that late Professor Vikram Sarabhai is the father of the Indian space program, who right in mid 1950s, he wrote to the then Prime Minister, Prime Minister Jawaharlal Nehru, and he got the space program moving in India. And as you can see, these are one of the prophetic words from Dr. Vikram Sarabhai. He realized that even the day-to-day problems of man and society, one should be able to tackle them using advanced technology. And we know that satellite research has certainly brought down the casualties that take place in super cyclones. For example, way back in 1999, the super cyclone that hit Odisha had huge number of casualties. But after that, thanks to ISRO's weather satellites, which gives us a full sort of prediction that there's going to be a super cyclone, after that, no other super cyclone did much damage to Indian regions. And here is the file pictures. You can see Dr. Vikram Sarabhai here and a young Dr. APJ Kalam, who later on became our president. And the second picture is another very rare picture. You can see Homi Bhabha, the Nobel laureate C.V. Raman, and Vikram Sarabhai. And the space program, indeed, in the 1950s, was launched with great prescient thoughts under the leadership of Professor Vikram Sarabhai. This is another file picture where you can see that scientists like Patrick Blackett, Professor Homi Bhabha, Professor Powell, and Dr. Vikram Sarabhai in intent discussion concerning the future of science in India. The next leadership came from another charismatic space scientist, Professor late Satish Dhawan, who sort of gave the right direction for various satellite launch program which ISRO has been doing essentially due to the leadership that was sort of represented by uh, late Satish Dhawan. Here is a file picture of late Professor Satish Dhawan, late former President Dr. Abdul Kalam, and the former Prime Minister Srimati Indira Gandhi regarding the future of science and technology in India. And here is another picture where you can see Dr. Abdul Kalam in jovial mood with Professor Satish Dhawan. Then came the leadership of another great scientist, Professor Yashpal, who also is no more with us. And right in mid 70s, he was involved with the SITE program of ISRO, which was taking education via satellite mode. And particularly, this was very popular those days in mid 70s in the western parts of Odisha. Then the space science and the probing space science using radio waves that was pioneered by two gentlemen. Here I'm showing the picture of Professor late A.P. Mitra, and one should, and this is for your general knowledge, that Dr. Mila Mitra is essentially daughter of late Professor A.P. Mitra. And Dr. A.P. Mitra, as well as Professor Govind Swarup, they were the pioneers of radio astronomy way back in 1960s. Regarding ISRO, of course, again, another charismatic space scientist, Dr. U.R. Rao, he gave the right direction to ISRO in the 80s and 90s. Unfortunately, he too passed away a few years back. So you can see that this is a picture as to how the space program of India started. There was not enough fund or technology to even carry the components of rockets those days. And you can see even bullock carts were used to transfer key components of satellite program from one place to another. And in 1975, this is a watershed moment in the history of India. India's first artificial satellite Aryabhatta was launched in 1975. I remember it vividly because I was in my 10th standard in Kendriya Vidyalaya school those days, and it had sort of an impact that will forever stay in my mind. And since Dr. Mila Mitra has advised me that I should also talk about my personal journey, so I think this is one point where I would sort of briefly go into my personal journey, because not only the launch of Aryabhatta sort of triggered my interest in physics and space science in particular, but even before, in 1969, when I was barely 10-year-old kid, that time the first men on moon due to Apollo 11 mission, where Neil Armstrong stepped into the moon, onto the moon, and declared a small step for a human being, but a giant leap for the mankind. So the space mission, I'm sure it captures the imagination of all young students, and 1969 landing on moon did so to me too. And 1969 was also the time when another thing happened. So I will talk about it, but let me first go to the other slide to um, talk about my personal journey.
Hello. Uh,
Yes, I'm trying to
okay.
share
You're
the
just sharing
screen.
that. Yeah. I just wanted
Yeah.
to make sure. Yeah, we can see this now.
Yes. Are you able to see the full view of the?
Yeah, we are seeing the full
Very
screen
good.
view.
Yeah. Yeah. Um, right. So, as I said, 1969, the first Men on Moon, it inspired me greatly to look at science in general and space in particular. So this is a file picture of my class group photograph. I did my schooling in Kendriya Vidyalaya at a small town called Puri. Many of you might be knowing about Puri, which happens to be famous because of Lord Jagannath's temple, as well as the Puri Sea Beach attracts a lot of tourists to the uh, town. And it's very difficult to spot where I am in this picture. One of the reasons being the picture itself is small, but here I am. And soon, when I sort of went to Bits Pilani, this is another picture where I am with my school friends, those who studied in Kendriya Vidyalaya Puri, and we used to do a lot of adventure because there was a place with, you can see that there is ruins, and we used to go about as small kids trying to hunt for treasure, because ruined house in various novels, they have this reputation of hidden treasure. So we would always with try to find out whether there are some hidden treasure around. uh, Later on in 2012, there was a school reunion at Puri, and you can see that to recreate our nostalgic feelings about our school days, we friends, we went back to our 11th standard classroom, and you can feel the surprise in us that we found that the chairs and the benches were very small. While when we were in school, we thought that they were sufficiently large. Essentially, we had grown bigger, and so those were the nice. And in 1976, I moved to Bits Pilani. This is a group photograph of some of us at Bits Pilani near the um, uh, museum, Birla Planetarium and Museum at Bits Pilani. Again, you might not be able to figure out who I am. It's here. I'm standing right in the middle at the back. And uh, in 2018, after Professor Stephen Hawking passed away, BITS Pilani organized a tribute lecture series uh, to pay respect to uh, late Stephen Hawking, and I was invited to give a talk. So this was my visit to my alumni, as an alumni to my alma mater, and this is with the organizers of this meeting. I'm being seen in one of the messes of Bits Pilan. Then later on, there was a alumni research talk where I was invited to give a talk by the director of the BITS Pilani Goa campus. And there also I shared some of my experiences at BITS Pilani. So there was the alumni research talks. I'm showing this picture because some of these places you might want to join after you pass out from school. So this is the central uh, uh, hall of the BITS Pilani Goa campus. Now, in 1969, something else had happened. I talked about the landing of men on moon, but around the same time, I discovered books written by one of the greatest magicians of India, late P.C. Sarkar. Those books I accidentally discovered in old trunks at my house, and I was told that they belonged to my uncle, Shri Girish Chandra Das Gupta. And I started reading them, and I was fascinated by the magic tricks. So, two things: interest in space due to the first men on moon, and then my interest in magic tricks. I realized while reading the books and also performing magic tricks in front of my school students that most of the magic tricks are based on physics. And that is what gave the impetus to me to learn physics. As you can see, later on, when I was giving a seminar or a lecture in some college in Delhi, I'm showing a magic where I show anti gravity, where this microphone is not slipping, falling towards the ground due to gravity. Similarly, in some of the Delhi University programs, I demonstrated how I can sort of pass a sharp blade through the finger of a member of the audience, and nothing happens. You will then, of course, I moved to TIFR after BITS Pilani for my PhD, and you can see here pictures of some of the very established physicists now. Here you can see Professor Anirban Gupta, who started out his career as a string theorist, but now he is a condensed matter physicist at the Bell Telephone Laboratories in USA. And here you see Professor Gautam Mandal, who is a string theorist and has been doing a lot of work on information loss paradox concerning Hawking evaporation from black holes. Here is another very well-known atomic physics expert, Professor Lokesh Trivedi. Gautam Mandal and Lokesh Trivedi, they are faculty members in Tata Institute of Fundamental Research. And luckily, we recently also had a TIFR first of its kind reunion, and it was called the 50 years of TIFR Graduate School. And here to commemorate the reunion, I got this picture clicked. There is this famous Vishnu culture in the terrace garden of Tata Institute of Fundamental Research, Mumbai. And it's a 1000 AD sculpture. And although it should have been in museum, but nevertheless, because of late Professor Homi Bhabha's influence, this historical sculpture is in the premises of TIFR itself. From TIFR, I moved to IUCA for my postdoctoral fellowships work. And here you can see Professor B.S. Satyaprakash, who currently is in USA in Pennsylvania State University, and he is one of the experts of gravitational wave research. Soon in 1993 itself, as Dr. Mila Mitra had sort of mentioned, that I moved to Delhi University as a faculty. And I want to show this picture because here there are some of the very outstanding physicists, like this is Professor N. Mukunda, one of the most brilliant theoretical physicists of our country, and another brilliant theoretical high energy physicist, Professor S.R. Chaudhary, and a great teacher on quantum theory and theoretical physics, Professor Kamal Datta. And there's a picture where there was a theoretical physics refreshers course where some of us gave lectures in the course. And this is a picture with one of my students who did a summer project with me, and now he is in USA. He has finished his PhD, and he is probably a faculty member in one of the colleges near New York. And this is a picture of some of my colleagues, theoretical physics colleagues in the Department of Physics. Here you have Professor Devajyoti Chaudhary, Professor T.R. Seshadri, Professor Amitabh Mukherjee, myself, and Professor D.S. Kulshrestha. And I will probably stop at this picture where I was the head for 8 to 9 months in the department. And during that time, University of Shanghai, some of the physics members of University of Shanghai visited the department. Right. I think I will get back to the slides which I wanted to talk about earlier. And let me.
Yeah, I think a lot of them have questions about how to get into fields of astrophysics. So we'll.
All right. Yeah, I can take the
No, you
questions
can.
now. It's
No, you can go ahead with your slide. I think that will give them some glimpses of those kind of careers.
are the slides visible now?
Yeah, they are visible.
All right. Very good. Yeah. Okay. Uh, so why was astronomy so important right from the prehistoric times? Because, of course, two of the famous celestial objects like sun and the moon, they not only were important for our daily survival, but as a timekeeper, both sun and moon played a very important role. This is Michelangelo's painting where he tried to depict how God created sun and the moon here. But of course, that was an artistic imagination. But we have to talk about science, and we know that uh, as soon as civilizations sprang up in different regions, with agriculture came civilization. Civilizations of different regions, they had their own idea about the cosmology. And here is in, if you read some of the Purans like Vishnu Puran and Bhagavat Puran, you will find that the earth is believed to be carried by four elephants standing, pointing towards the four cardinal direction, east, west, north, south, and they are supposed to be standing on the Kurma avatar of Vishnu, and who the Kurma avatar rests on the Sheshanaga. So this was the so-called Puranic times, how they viewed the cosmos. But then the Buddhist, they had their own idea where the Kala Chakra, that means the wheel of time, was important, because Buddha was one of the early philosophers in the entire world to have realized that nothing is permanent, everything changes, and it is the wheel of time which causally links different events. And Buddha weaved out his own philosophy around this wheel of time. And then when Renaissance sprang up in Europe around 14th century AD, suddenly there was a great reawakening. They started questioning the religious texts and went into trying to understand things from a scientific point of view. And around that time, Galileo, the father of physics, he sort of laid down the basic rules that one still uses in physics. And a mechanistic view of the world was represented by this Renaissance period art, where a shepherd boy, when he is wondering about the beautiful nature, trees, sun rising, stars, he wants to know what is the basis. And he peers out of the globe and see that they are all run in a mechanical way in terms of wheels and gears. So that is basically our modern day principle of science, that we try to understand the working of nature using experimentation and modeling them in terms of rigorous mathematics. And in particular, in astrophysics, we study various cosmic entities in the universe, and there is a whole discipline called cosmology, which is a sub branch of physics, whose main aim is to study the origin, composition, structure, and the large scale evolution of the universe. And basic unit of the cosmos is essentially galaxies and so on. I'll come to that, but a little bit about space science. We know that ISRO was also very successful in launching the Chandrayaan-1. In its first mission itself, it became successful, and because of Chandrayaan-1, hard evidence was discovered concerning water on moon and so on. And Mangalyaan, its main purpose was to look for methane in the atmosphere, because there was a report that although the soil, Martian soil, doesn't have methane, but the atmosphere, there was a report earlier that there was a trace amount of methane. So one of the purposes of Mangalyaan was to make elaborate studies on whether there is indeed methane in the atmosphere. Right. So space research, we have already seen that one of the biggest outcome of space research was to see water in the subsoil of moon, and the jury is still out as to whether methane is in the Martian atmosphere. Right. But ISRO, in collaboration with many of the scientific research institutions of India, like PIFR, IUCA Pune, IIA Bengaluru, Raman Research Institute Bengaluru, and so on, they launched the multi-wavelength telescope on board Astrosat satellite, and it is indeed sort of leading to very wonderful discoveries like crab pulsar, some of the X-ray emission between the crab pulsar subpulses. They have created a lot of interest in the scientific community. Similarly, the Astrosat mission has also been seeing gamma ray burst in the hard X-rays, and some of the UV stars that emit copiously in the ultraviolet rays, that are also being studied by the Astrosat. So one of the career points could be that students who are interested in astronomy can sort of join the Astrosat research and do pioneering work, because this Astrosat is orbiting around the Earth and collecting data from any kind of transient source or any kind of active galactic nuclei which are associated with supermassive black holes. And these are the main scientific goals of Astrosat, that one would like to see pulsars or neutron stars, and similarly white dwarfs, black holes, supernovae remnants which come because of explosion of massive core. Similarly, quasars and blazars, these are the active galactic nuclei, where at the center there are known to be supermassive black holes. Right. And so in the coming few minutes, I will briefly describe about my current interest in research. As I've already showed this slide before, that the basic building blocks as far as matter in the universe is concerned are these galaxies. Now, each of these galaxies, okay, they contain more than 10 to the power 11 stars. They are really very massive objects. And here is a closer view of a spiral galaxy. As you can see that in this galaxy, most of the stars are in a disk form. They're all going around the center. So this is the Andromeda galaxy. Here is another galaxy which happens to sort of exhibit its full face on to our line of sight. As you can see, the magnificent spiral arms, and this is a bulge of the spiral galaxy. At the center, if you study the motion of stars and matter, you will see a supermassive black hole. Some of you may already know that 2020 Nobel Prize in Physics was awarded to Roger Penrose for his theoretical research showing that black hole singularity is something which is must for any gravitational collapse. And the other half was shared by Professor Reinhardt and Professor Andrea. They independently, Professor Reinhardt from Germany and Professor Andrea from USA, they independently studied the stellar motion around the center of our Milky Way galaxy and conclusively exhibited that there is a supermassive a black hole which is 4.5 million times heavier than a black hole having mass of the order of 2 into 10 to the power 33 grams. And one of the key questions these days is how did the supermassive black holes form at the heart of these galaxies so early on? And this is one area I am researching on. I have given some model as to how Bose-Einstein condensation of dark matter, which are bosonic, their collapse can lead to supermassive black hole at the center. There is another spiral galaxy which happens to show itself in its side view. That means the galaxy is being seen edge on. You can see the disk of the galaxy where the spiral arms are, and there is the bulge of the spiral galaxy. At the center, you have the supermassive black hole. And galaxies, of course, come in all kinds of forms. Here you see spiral galaxies, different spiral galaxies. Then there are also elliptical galaxies, which don't have disk shape or spiral arms. So this is one elliptical galaxy. This is another elliptical galaxy, which is called the Sombrero galaxy because of the Mexican hat-like structure. This is another spiral galaxy. You can see that the stars, the density of the stars are very high at the core, where again, all these galaxies have supermassive black hole at the center, and the density of the stars gradually decrease so that very far away, the number density of stars is very less. Here is another very disturbed galaxy because of interaction. That's why you can see matter being thrown out because of collision of two galaxies. And the other interest which I have is in the generation of gravitational wave from collapse of neutron stars. I have been working on fast radio bursts, which are mysterious objects which show up in radio transient with duration of the order of few milliseconds. And the question is, what are they due to? And it could be collapse of neutron stars, it could be magnetars. There are many fascinating topics in both astrophysics and cosmology, where currently our model is that the universe began in a very dense and hot state, the so-called the Big Bang epoch, and the universe kept expanding. And because it's a system, it's a isolated system. As it expands, it cools down. And we are today here when the temperature from almost infinite temperature, it has come down to about 3 degrees Kelvin, 2.725 degree Kelvin at the moment. But in between, what happened was, this was around 3 lakh years back when the temperature had come down so that protons and electrons, they formed neutral hydrogen atoms, and then neutral hydrogen atoms formed galaxies, stars, planets, and in the planets, slowly, in our planet particularly, many complex molecules like amino acids, DNA and RNA got synthesized, and living systems were formed. And today we have intelligent living systems like us, who all are made out of stellar material, no doubt, but we are all made out of matter, but these matter, they are trying to ask what are the laws followed by matter. So this is one of the biggest philosophical questions. And so to sort of end my lecture, I would uh, uh, there are a lot of things to say, but I would not. Just to point out is that although galaxies are seen because of the stars in the disk and the globular clusters, but we are actually embedded. All galaxies have a dark matter halo, and no one knows what this dark matter is made out of. And similarly, there is also evidence that expansion of the universe is the rate of expansion is increasing with time. So there is some kind of anti-gravity, some strange exotic substance causing anti-gravity, and that exotic substance has been given the name dark energy. So dark matter and dark energy, still no one knows what they are made of. These are outstanding questions of cosmology. I think what I will do is I'll stop here. It's more important that we have a lot of time for interaction.
So thank you so much for giving us all kinds of glimpses into the world of astrophysics. And of course, as you mentioned, this year the Nobel Prize in Physics went to the supermassive black hole. So that was very interesting that you discussed that with the students. And
Thank you. Thank you.
yeah, and uh, it was great to see your college days and finally get your story about magic, how you're interested in magic, because pretty often I see you posting on that. So that was an interesting glimpse.
That's right.
So
But nowadays, we could learn magic tricks only from books. But nowadays, those students who are interested in magic just go into the YouTube.
right,
Massive magic tricks have been revealed how they work. So it is very easy for students to pick up how to do magic. We had to struggle as school students to, on our own, practice all kinds of tricks. Uh,
right. So yeah, Arjun, I see a lot of questions. So would you please bring some too, sir? I think you're on mute.
Yeah, yeah. So yes, we have been getting a lot of questions, and so some of them are related to their careers in astrophysics and astronomy, and some of them they were mostly want to know more about astronomy and regarding what you have been doing. So let me just take a few questions. So first
Great.
question I'll take is from Veda. So she says, "Sir, tell me about your invention, direct detection of gravitational waves." So she refers to the discovery of gravitational.
Yes. Well, that's not my invention.
Yes.
Uh, Done by the group LIGO. LIGO stands for Laser Interferometric Gravitational Wave Observatories. And uh,
And
uh,
we also had Dr. Tarun Shorudeep from
yes,
ICER who gave
was,
a
he
short talk
was the
with us.
spokesperson. I think he's still the spokesperson of LIGO India.
Right. Yeah.
There is a LIGO coming up near Aurangabad, and so the LIGO of USA, they are shipping the components, and they are soon going to be installed in a place near Aurangabad in Maharashtra, and we will soon have our LIGO India, and it is projected by 2022 to 2024. LIGO India will be operational. So those who are interested in catching gravitational waves, they can do so. I study the theoretical aspects of certain kinds of exotic gravitational wave source. So I'm not involved in the direct detection of gravitational waves. Direct detection of gravitational waves, some of the people who have been doing exciting work these days is Professor Anand Sen Gupta of IIT Gandhinagar, Professor Archana Pai of IIT Powai in Mumbai. And those who are interested, they can go to their website and look at the recent fascinating discoveries they have been involved with concerning direct detection of gravitational waves. So direct detection basically involves, because gravitational waves are nothing but undulating changes in the geometry of the space-time, and to detect them directly, you have to have devices where when the gravitational wave is incident, the length changes with time because it is the geometry which changes, and how to measure these changes in light in the length. And that is where a Fabry-Perot interferometer is utilized. It sounds very easy, but the actual direct detection is a big challenge because the change in the length due to standard gravitational wave that are coming in is only a fraction of a proton's radius. As you know, proton's radius is 10 to the minus 15 meter, while the change in the length due to the gravitational wave coming from neutron star binaries or black hole binaries is only about 10 to the minus 17 meters or so. So you can see, how do you measure changes in length which are 1/100th of the proton diameter? That is the experimental challenge, and that's where Ray Wise was instrumental. He is the father of the LIGO detector, and he was awarded the Nobel Prize around 2016 or 2017. Kip Thorne, Barish, and Ray Wise, they were awarded the Nobel Prize for the gravitational wave research. Right. And my interest in gravitational waves is that I'm looking at objects, theoretical objects. They have not been found in the nature. Theoretical objects that could carry both magnetic charge as well as the electric charge. And I, along with my student Sartaj, we have been looking at the gravitational wave and electromagnetic wave emission from two such, they are called dions which carry both magnetic charge and electric charge, their interaction, what kind of gravitational waves as well as electromagnetic waves are emitted.
Yeah, okay, sir. So thanks a lot for the answer. So I would like to take another question. So next question is from Kaustav Kulkarni. He's asking, sir, what should we do to become astrophysicists? So that is related to the careers.
Very good. Yeah. So as you know, that astrophysics is a branch of physics that uses the laws of physics to understand the celestial objects, the cosmic objects. And obviously, if you want to become an astrophysicist, you have to study either engineering or masters in physics. So in both methods, you can become an astrophysicist. And in particular, what you have to be very disciplined about is numerical problem solving, both in physics and mathematics. Because by now, many of you would have realized that the language with which nature speaks to us is in terms of mathematics. So mathematics is the key to understand laws of physics, and therefore you have to train yourself well in mathematics as well as problem solving physics. And that requires, it's not difficult, it's just that every day you have to allocate 4 hours, and with great discipline, you solve problems in both physics and mathematics. And if you do either masters in physics or BTech in particularly mechanical engineering or electrical engineering, then you can join the PhD program in astrophysics and astronomy.
Okay, thanks a lot, sir. So another question I'll take from Ronak Tripathi. He's asking, sir, why was the Big Bang caused?
That's a very good question. And the answer is not known yet. And physicists, in particular string theorists, they are trying to see what could have caused the Big Bang. Then another kind of quantum gravity theory pioneered by Indian origin physicist Professor Abhay Ashtekar, who has developed the so-called loop space quantum gravity. Their work suggests that the universe was symmetric. So in the past, before the Big Bang, there was a contracting universe, and then it passed through a very tiny size, and then again it expanded. And today we are seeing an uh, expanding universe. But whether it is string theory inspired model or whether it is Abhay Ashtekar inspired loop space quantum gravity model, these are theoretical models. These are theoretical models, and uh, they have not been corroborated via experiments. As you know, that physics is the study of nature herself, and might give lot of models, but ultimately, unless the theoretical models are corroborated by experiments, we can't be sure which theoretical model is the correct model to explain the natural phenomena. So today, we still don't know whether it is a string theory which describes the quantum behavior of gravity, or is it the loop space quantum gravity that explains quantum gravity. No one knows, because to test them experimentally, one has to accelerate particles to energy of the order of 10 raised to power 22, okay, 10 raised to power uh, 28 electron volts. Remember,
That's a lot.
Hydrogen atom, the binding energy, that is, if you want to split the hydrogen atom into proton and electron, you have to supply 13.6 electron volt. But to test quantum gravity, whether string theory or loop space quantum gravity, you have to build accelerators which could accelerate particles to energy of the order of 10 raised to power 28 electron volts. That means 28 zeros following one, that many electron volts. I don't know whether human beings should be having that much of uh, uh, financial resources to create such accelerators, because accelerators are very expensive devices.
Yes.
It's a real bottleneck as to why we still don't know which is the correct theory of quantum gravity. That can only explain what caused the Big Bang creation of the universe that we are in.
Okay. Okay. So I'll take one more question. So this question is again from Veda. So she's asking, sir, can you tell me the difference between astrophysics and theoretical physics?
Very good. So theoretical physics essentially is using advanced mathematical tools to understand particle interaction. That's the so-called theoretical high energy physics, trying to find out a unified model. As you know, Abdus Salam, Steven Weinberg, and Glashow, they unified electromagnetic theory with weak interaction. Similarly, there is a strong interaction theory called QCD, quantum chromodynamics, and people are looking at whether you can have a grand unified theory which will unify strong interaction with the electroweak theory. So theoretical physicists, they study various unification models like uh, grand unified theories, string theories. Similarly, there are theoretical physicists who are looking at very fascinating condensed matter problem like anions in condensed matter systems, and looking at uh, topological insulators, looking at Majorana quasi-particles in condensed matter physics. Similarly, theoretical physicists also look at how to produce room temperature superconductivity graphenes with all kinds of fascinating properties. While astrophysics could be either theoretical or observational. Observational aspect of astrophysics traditionally is called astronomy, and there are all kinds of astronomy programs: gamma ray astronomy, X-ray astronomy, radio astronomy, optical astronomy, and so on. And nowadays you have gravitational wave astronomy and neutrino astronomy, because there are many neutrino observatories like Ice Cube and many other. India itself, INO, that project has been stalled because of environmental issues. So neutrino astronomy is another field. While theoretical astrophysics, one learns advanced mathematical methods, computer languages to study theoretically um, all kinds of bizarre cosmic objects like quasars, pulsars, magnetars, gamma ray bursts, fast radio bursts, using theoretical tools and try to make use of corroborated laws of physics to understand these cosmic sources and various uncanny celestial events.
Okay. Yeah, so thanks a lot, sir, for answering the question. So do we have time for one more question now? Or
Yeah, but let me ask him one more related to these careers. So somebody had a question, which are the places or institutes in India that one can do astrophysics? I mean,
Very good. Yes.
you're in the
India,
university. Yeah.
yeah, India, there are many institutes where research in astrophysics can be done, starting from Tata Institute of Fundamental Research, Mumbai, IUCA, which stands for Inter-University Center for Astronomy and Astrophysics at Pune, then Tata Institute's Radio Astronomy Wing, the so-called NCRA at Pune is also there if you are interested in radio astronomy. Similarly, you have Raman Research Institute, where there is a whole group of theoretical astrophysicists as well as radio astronomers. Similarly, IIA, Indian Institute of Astrophysics in Bangalore, there that whole center is dedicated to research in astronomy and astrophysics. Indian Institute of Science, the physics department, has several theoretical astrophysicists as well as ast- astrophysicists who are also interested in observations. Then many IITs, you name any IIT, you will find a handful of astronomers and astrophysicists. And similarly, ICERs have many faculty members who research in astrophysics. Universities like Delhi University, then Punjab University, Patiala University, Bangalore University, Pune University. There are many universities where there are quite a few astrophysicists working on challenging problems in cosmology and astrophysics. Similarly, Jamia Millia, it has a Center for Theoretical Physics, where there are some people who are working in astrophysics as well as cosmology. So astrophysics as such in India, there is absolutely no problem, because most of the organizations in India, they are indulging in research in astrophysics.
So I think that that's it, right, Arjun? Probably.
Perhaps I must as well add, those who want to do research in space, not onto astrophysics and cosmology, there is a institute where in Tiruvananthapuram is affiliated to ISRO. It's called Indian Institute of Space Technology. So those who are interested in, and there are also astrophysicists in Indian Institute of Space Technology as well. So both, they conduct research in space research as well as astrophysics research. So in Tiruvananthapuram, you can take a look at the website of Indian Institute of Space Technology.
And that is by ISRO, right? That institute?
Yes.
Action.
Yes. Yes.
Yeah. So any last advice on how students can stay interested and build up skills in this field?
Yes. So first of all, we know that if you are really motivated in carrying out research in astrophysics, first thing you have to learn thoroughly is physics problem solving, and learn as much of mathematics as you can. So you do lot of proving of mathematical theorems. You take calculations using mathematics like trigonometry, calculus, and so on. All right, and uh, and it requires a disciplined approach. You have to really take a pen and a paper, sit down, and with full concentration, solve the problems. Don't look at the solution immediately. You think. After all, you have to train your mind to develop the imagination in physics as well as mathematics. That imagination can be developed only through disciplined work and looking at various puzzles. Other thing I did not mention was that right from my childhood, I was also interested in solving puzzles and brain teasers. They give you a sense of imagination because not only logic and going step by step is important, you have to also have a quantitative imagination. And that comes only by solving challenging problems and brain teaser kind of problems.
Yeah, that's great advice, and I think they can easily try to build up their skills with puzzles and challenges like that.
Yes.
And of course, you said you are part of the group that supports them in the physics Olympiad, and similarly, we ourselves are organizing an astronomy Olympiad this time,
Oh, fabulous. That's
like
very
a
good.
astronomy challenge, and so that many of the students participating today are taking part in that challenge. So,
Oh, that's very good. I'm really happy.
right. So, with that, thank you, Patrick, sir, for coming and interacting and speaking to our students.
My pleasure, Dr. Mila.
Yeah, and thanks, Arjun, for supporting and bringing the questions to
Yeah,
him.
thank you, ma'am.
Thank
Thank
you,
you, sir,
Arjun.
for
Thank
coming.
you, Rahul.
Yeah.
Thanks for sort of putting the whole thing together. Thanks.
Okay, so everyone,
Thanks, ma'am.
all the students, uh, thanks for joining us here today. And we have another webinar coming up on Thursday, and that is on astrobiology. So you'll hear a different aspect, a different topic. And again today, thank you, Patrick, sir, for joining us, and thank you, students.
Thank you.
And
Thank
with
you,
that,
Dr. Mila. Thank
we'll close
you,
the session today.
Arjun and Rahul. Goodbye, and everyone stay safe and take good care. Goodbye.